Welcome to We Learn. This is session number 8, part 3 of RDBMS on relational data model. In this session, we are going to cover topics multi-value dependencies, use of multi-value dependencies, restriction of multi-value dependencies, ER model and normalization, एंड फिफ्थ नॉर्मल फॉर्म। जैसे कि हम पिछले सेशन में नॉर्मलाइजेशन का वन नॉर्मल फॉर्म, सेकंड नॉर्मल फॉर्म, थर्ड नॉर्मल फॉर्म एंड BCNF पढ़ चुके हैं। नाउ उसके बाद जो हमारा BCNF आता है, फोर नॉर्मल फॉर्म आता है, दैट इज कॉल्ड है मल्टी वैल्यू डिपेंडेंसी। देयर आर डाटाबेस स्कीमास इन BCNF दैट डू नॉट सीम टू बी सफिशिएंटली नॉर्मलाइज्ड, सो दैट कंसिडर डाटाबेस. So their classes consider here course, teacher and book, such that in short we take it the CTB that belong to classes, means that T is qualified to teach C and B is required textbook for C. There you see the relation like this, and the database is supposed to list for each course the set of teachers, any one of which can be courses, instructor, and the set of books, all of which are required for the courses, no matter who teaches. Like this kind of you see that there are the multi-values dependencies are created in this situation when where the many teachers can take the books of the many subject and the courses also here. So like this, there is a multi-value, one thing can be depend on the various things, so called here the multi-value dependencies. And you can consider this example that R is a relation and schema with a set of attributes that are partitioned in three non-empty subsets, that's are Y, Z and W. So we can say that Y that belongs to the double arrow shown here to Z, that show means Y multi determines Z, means multi values to be determined of Z. If and only if for all possible relation that R relation belong to of R. So now these are the shown here, Y1, Z1 and W1 are the values that are belong to relation R, and Y2, Z2, W2 are the values that belong to relation R. If these are true, then Y1, Z1, W2 that belong to relation R and Y1, Z2, W1 that belong to relation R. You see can here like the value W2 and W1 that are changed over with the Z1 and Z2. Note that the behavior of Z and W are identical. It follows the Y that multi determines the Z and Y that multi determines the W. Next was example, it's continuing here, the course and that belong to teacher and the course related the books. And the above formal definition is supposed to formalize the notation that give a particular value of Y course. It has associated with the set of value Z, that is teacher, and set of value W of book. These two sets are same sense independent of each other. That's shown you in the previous slide how the course and the teacher are related and the course book are related, the teachers related with the courses. Similarly, the other multi-value dependencies are here. So it's very difficult to extract the exact condition to which are the course and teacher book are related. So if Y tends to Z, that is the Y is multi-value dependent on the Z, we need indeed that we have in above notation Z1 is equal to Z2. That claims how? This. The use of multi-value dependence is what? We use multi-value dependencies in two ways. One, to test relation to determine whether they are legal under a given set of functional and multi-value dependency. The second is the specify constraints on the set of legal relations. We shall thus concern the ourselves only with relation that satisfy a given set of functional and multi-value dependency. Means हम इस दिस पॉइंट टू से दैट हम मल्टी वैल्यू डिपेंडेंसीज यूज करते हैं बिकॉज अगर हम जब टेस्ट करने हैं रिलेशन जिसके से हम डिटरमाइन कर सकते हैं उसकी क्या लीगल वैल्यू है, किस फंक्शन के अंदर हम मल्टी वैल्यू डिपेंडेंसीज बन रही है, एंड स्पेसिफाई करते हैं कुछ कंस्ट्रेंट होते हैं. दैट इज द यूनिक रूल दैट कैन अप्लाई ऑन द पर्टिकुलर attributes and the set of legal relation. We shall thus concern here on ourselves only with the relation that satisfy a given set of function and multi-values dependencies. So if a relation R fail to satisfy a given multi-value dependency, then we can construct a relation R that does not satisfy multi-value dependency by adding the tuple to relation R. That is the fourth normal form we are talking, that is multi-value dependency. One can depend on the many things. So a relation schema R is in four normal form with respect to set D for functional and multi-value dependency. If all the multi-value dependency are D plus from to alpha to tends to beta, that already shown you in the previous example, and alpha belongs to relation R, beta belongs also relation to R, that at least one of the following should be hold. Alpha tends to beta is retrieval to that beta belongs to alpha, and that is the unions is that belong to alpha and beta combination of their columns and the form a relation R. So alpha is the super key of schema R. If a relation is in the four normal form, it is in BCNF. That is very necessary condition for the four normal form, as we told you already in previous session about the 1, 2 and 3 so on BCNF form. Similarly, the condition if come in the four normal form, it should be cleared by the BCNF. There is some restriction of multi-value dependency. The restriction of D to R I is considered a relation, and D I is consisting of like the what? All functional dependencies in D, that is multi-value dependency that include only attribute of R, and all multi-value dependency of the form, that is A tends to have multi-value with the combination of B and relation R, where alpha is a subset of Ri and alpha, that is the multi-value of the beta, is in D. Here the multi-value dependency can be extracted, and there is the ER model and normalization. What is ER model? Is that we are working on जैसे कि database हम tables create करते हैं, that also can represent by the ER model. So in the ER model, diagram is carefully designed by identifying all entities correctly. The table generated from ER diagram, that is ER diagram, basically that should not be for the normalization. That means whatever table and the relation are made, that is clearly to be reflected in the ER model. And however, in the real imperfect design, there can be functional dependency from non-key attribute. That is non-key attributes which are not a makeup, particular constraints are not applied on it, are the non-key attribute, and the entity is a real world thing that can be considered anything. You can consider the example the student, and any object which have some attribute that through which you can identify it. Example, that take on a student. It's student must have their name, designation, and courses, roll number, anything that identify this student are called also attribute. So, and the example more you can consider employee, entity with attribute like department number and department address of a functional department, that number, department address. Like see again what you want here. We are talking here about the employee. Employee is considered here entity. Yes, sure, we can consider like student we taken here our entity, and the name correspondingly taken here, name, designation, roll number are. Similarly, an employee is taken an entity and its attribute can be considered. Employee concerned can be linked with the particular department number, department address, and there are the function department number. That dependency is what? This some dependency is what? Function department number that gives the department address. So this is good. That design would be made department entity. So function dependency from non-key attribute of a relation set possible, but rare. Most relationships are the binary. Next, after that clearing this fourth normal, fourth normal form, we have goes to enter the fifth normal form. That is very clear to in this form. Tables are goes to very clear form and easiest through which we can easily do insertion, deletion, and updation. So fifth normal form is the ultimate normal form for with respect to projection and join. That which account for it, alternative name, projection, join, and normal form. This is a relation in the fifth normal form is guaranteed to be free of the anomalies, and that can be eliminated by taking projections. That is the for relations in the fifth normal form. The only can dependencies are those that are implied by candidate key. So the only valid decomposition are the one that are based on the candidate key. And now the table are the very simplest and easiest form, so you can easily do this insertion, deletion, and updation in the table. I would like to hear one more comparison between here the BCNF and 3NF. That what is here. We have seen the two normal form in the previous session. We have considered about 3NF and BCNF also. That is always possible that 3NF design without scarcifying a looseless join or dependency prevention, and nevertheless they are the disadvantages to 3 normal form. If we do not eliminate all this transitive dependency, we have to use null value to represent some of this possible meaningful relationship among data items, and they are the process problem for repetition of information. So the difficulty to be repetition of this information. So I would like to tell you that after the fourth normal form we have covered in this session, it should be very clear to how we move from 1, 2 and 3, then BCNF, then 4. After that we move to fifth normal form. So 1 normal form, remove the one cell should not contain multiple value. 2 that form the primary key. 3rd, remove the transitivity. 4, that multi-value dependence. BCNF, that use the candidate key and make the separation through which you can do easily insertion and deletion. The 4th one is the multi-value dependency, through which you remove the multi-value value that is to be dependent here. And finally in the fifth normal form, table should be in the very clearest form. This is the exercise that you can try it by yourself. What is difference between 3 normal form and the 4th normal form, and explain the use of multi-value dependency. That's all in this session. We are winding up here. Thank you so much. Happy learning. We learn.